A big thank you for PCBWay for sponsoring the new boards. The result is meticulous. I'm really happy with it. With PCBWay, you always know that when you send your parts for order, it will come out perfectly at a very high precision. So I'm not surprised that if you look at the final result of the laser direct imager, everything worked out perfectly fine. So if I just place in the mirror, it will exactly hit the photodiode, and that's all because PCBWay is able to provide very neat tolerances. Also, the laser was already almost at the perfect position. And well, let's look at a bit further. So the laser direct imaging head is connected with one FlatX cable to a main board, which you find here. So here we can see that there are two stepper drivers, TMC 2209 connected, and then below the main board there is a compute module, which you find here, and on the compute module there is an ESP32S3 and a Lattice UP5K. And here you see a result of an exposure where I made the pattern PCBWay. And that is because champions team with PCBWay. So here you have the compute module in KiCad. And once I've reviewed it, I simply click PCBWay, which is a plugin you can install for KiCad. And then it's processed. And I open up my Firefox, and then I can ship this directly to my house. Besides the boards, you also need the parts. So each footprint has a manufacturing ID associated with it. You need to generate a legacy bill of materials, and here you see a couple of scripts. You just run any of these scripts, and this will also create an XML file. Then you open up KiCast, you select the correct BOM file and the distributor from which you want to get the prices. You then generate a LibreOffice Excel file where you can change the quantity. For instance, let's say we desire 3 boards. Then these are the numbers you need to order. And here on the right, you find the order codes at Mouser. You then submit this to them and they will ship it to you. I always order the PCBs with stencils at PCBWay so I can easily put solder paste at my boards. I then populate the boards by hand, place them in a furnace, and if all is well, the boards should work directly. So let's print a pattern with the laser direct imager. Here I'm connected to the ESP32 using Thonny. So let's launch the web server. I import my boot script, and normally I manually run the main method. It's just for simplification. This will initialize all the modules I need, and it will start a web server at this address, which you can change in your config.json, where you can set settings like your Wi-Fi password. So we go to this address. We log in with the password hex. We upload the print job we desire. And then you can start a print job. So you select the file name you want and you set a value for the laser power. And now this will result in a current of say 0.3 amps. We click start. The laser head moves to the starting position. We place the substrate. The laser exposes the substrate, and in the process window we can view the printing status. And once the process is finished, I develop it with water, and you end up with this nice little pattern with PCBWay. And of course I will be working on better printing results. And one of those results with an actual printed circuit board you can find on my Hackaday page. In my current module I use a polygon mirror motor where I place the polygon mirror with my prism. People might wonder what happened to the PCB motor. So there is this idea that you replace the polygon mirror motor with a printed circuit board motor. And as you know earlier, I made an actual module with a printed circuit board motor, which works. The challenge is it just doesn't work that well. So the key issue which still needs to be solved is that the rotation needs to be stabilized. And I think that can be solved by replacing the driver. So the new version and this printed circuit board motor can be placed in the laser head. This new motor has an option that you replace this chip with a chip which has a driver circuitry integrated. So that is nice. I also want to thank PCBWay for sponsoring all the printed circuit board motors. PCB really likes them as well. I like them also. It's just that for the final product, which I hope to ship, I will stick to polygon mirror motors because they are much more reliable. So this is still something for the future or for people who want to play around with printed circuit board motors.